In this video, we're going to prove that the limit as x approaches 9 of 4 over x is equal to 4 over 9. Now, we're going to use a very renowned method of proving the limit. It says for a function f of x that is defined in an open interval about c is 9 in this case, except possibly at c itself, the limit of f of x as x approaches c is the number L if for every number epsilon greater than 0. Epsilon would be the difference in y values for the limit. This will be epsilon, epsilon. So the whole thing will be equals to 2 epsilon. There exists a number delta greater than 0. Delta will be the difference in the x values. Delta, delta, the whole thing, 2 delta. This implies that 0 is less than the absolute value of x minus c is less than delta. And that statement leads to the statement f of x minus L is less than epsilon. So we set up the equation like this. Negative epsilon on one side, positive epsilon on one side, because we're solving an inequality. We try and isolate x. In this case, we factor x out, multiply by 9, subtract 4 from each side, and we end up with 36 divided by 4 plus 9 epsilon is less than x is less than 36 over 4 minus 9 epsilon. Find deltas greater than 0 that puts 9 minus delta, comma 9 plus delta in the interval. In this interval, we're trying to find the delta value that will put this range of values in this interval. Another way of saying is that we're trying to find the delta value that will satisfy x in this equation. And when we break down the limits of the interval, we get that the minimum is 81 divided by 4 plus 9 epsilon. Therefore, this value will place x between 36 over 4 plus 9 epsilon and 36 over 4 minus 9 epsilon. Therefore, this statement is true. The absolute value of 4 minus 9 will be equal to 0. The limit as x approaches 9 of 4 over x is equal to 4 over 9.